Today, we will be discussing the cluster records function in VantagePoint. To demonstrate this function, I have here a data set of paragraphs from 3 authors in the Project Gutenberg database: Chesterton, Austen, and Shakespeare. Now, what the cluster records function is going to do is to take your data set of records and, using their text, plot these records on a 2-dimensional map to demonstrate how they relate to one another. So records that are closer to each other in this 2-dimensional map have more similarity in their text, and records that are farther apart have more dissimilarity. So to run this function, the first thing we want to do is set training fields. And we do this by assigning the training field meta tag. Now, by default, VantagePoint assigns title and abstract as your training fields. And I do recommend choosing a field that is similar in that it has what we would call free text, which has, like title and abstract, a wordy, prosy quality. So within this data set, since we are talking about paragraphs in works by these authors, the paragraph field is what I want to assign as my training field. So to do this, I am going to come over in the summary screen to meta tags, right-click, and set meta tags. Scroll toward the bottom and select training field. So now the training field meta tag has been added to our paragraph field. So now I'm just going to run cluster records, and I do this by coming to the Analyze tab and the Explore section. Clicking this button, cluster records, and this is just a warning that this may take a while to complete. Now, this data set only has just under 1,500 records, and so this will absolutely finish in time to do this demo. However, if you have in the, say, tens of thousands of records in your data set, this won't be an instantaneous process. So the first thing it's going to do is build the knowledge base. Now, for all of the AI operations in VantagePoint, this is going to be our first step. And what it's doing is, for each record in the data set, it is taking the text data from those training fields and abstracting it into a series of numbers representing that text. So a little over 1,400 records means we have 1,400 lists of numbers. So then what the cluster records function does is takes that list of numbers and performs dimensionality reduction to take a list, however long the data set needs, and transforms it into a list of 2 numbers, an X value and a Y value, which we can then plot in 2D space. So right here, we have the output of our cluster records function. And the first thing I will draw your attention to is this topographical information. So as we can see, this generates a sort of topographical map. And within some of these more dense regions, we can see more dense and similar pockets of records within the data set. So let's say we have this big chunk right here. I can highlight those records, and then over in the detail window, I can preview what those paragraphs are, and I can see that these records have a lot of similarity between their text. And we can see another similar pocket over here. And as you can see, if you open up the detail window, you can preview some of this text as well. So then the next thing we can do in our analysis is, if you already know some categories that your data might be divided into, we can color code these dots and get a feel for how those categories relate to one another. So I am going to open the cluster record setting using this gear icon. I am going to remove the contour simply because it's easier to see, and apply author as my color coding field. So now we can see our 3 authors, and we can see that they have very distinct regions within this plot for the records that those authors have generated. So for example, Austin are these blue records. And we can see that even though they're not linearly separable necessarily, I can still draw a line around this Austin cluster and see that those records are stylistically distinct from the Chesterton and Shakespeare records. Likewise, I can also see that there is a region here where there is a lot of overlap. And so we can see which records are maybe not as mathematically distinct from one another, and get an idea of which records within these categories have overlap and have common themes. One other thing I will show you in this data set is that we can also apply this to, I did say these were works from 3 authors, and each of them in this data set has 3 works. Now, we limit the number of colors available for categorization in this process, because past a certain point, adding any more colors is not going to be visually distinct enough to be able to see a difference. So we limit this to fields with 7 categories or less. Now, there are 9 works in this data set, so I'm actually just going to be looking at the Austen and Shakespeare specific works. So back to the gear icon. This time I'm using my group names that I already assigned. And again, because we are limited to 7, the Chesterton records all ended up grouped together. Now, for the purposes of demonstration, I don't necessarily want to be looking at the Chesterton records, so I'm going to come over here and make those a little less visible. So now, looking at just our Austen and Shakespeare records, all of the dots are in the same place, but now different coloring has been applied to them. And even at this higher level of granularity, we can see that the Emma records are still visually distinct from the Persuasion records and the Sense and Sensibility records. The Shakespeare records are not quite as distinct, but you can still see that each work has some stylistic uniqueness to it. One last thing, I will show you that this applies to all manner of data that you may want to use in VantagePoint. So for example, I have another data set here, and this is for Web of Science records that were generated using a series of search terms. And so I can also cluster records on this Web of Science data. Just another moment longer. And here we see the same plot, the same contour mapping. And so even without adding categories and without adding the contouring, if we don't know our categories ahead of time, the cluster records plot will just generate all gray dots. And so we can take a look at where some of these natural clusters occur. So for example, let's say I don't know what any of these search terms were. I think I can be fairly confident that these records over here probably belonged to one search because they are so distinct from the rest of the data set. And as we can see, the vast majority of them are stochastic programming. So then if I want to put my colors back on, admittedly, some of these are not my field of expertise, but I do feel comfortable with stochastic programming and genetic algorithms. So I am going to focus on that. And as predicted, this little cluster up here all seems to belong to the same search, with the exception of a couple of genetic algorithms in here, as well as these genetic algorithm records, while not as distinct as this cluster up here, does go to show that they do tend to group in the same place. Now, this analysis just goes to show how related these two categories are to each other, in that the genetic algorithm records are a little bit harder to differentiate between all of the rest of them, but they especially have overlap with stochastic programming. Likewise, this very distinct stochastic programming section has a couple of genetic algorithm interlopers. And so we can use this analysis to determine what records are similar to each other and what categories have a lot of overlap with each other. The last statement I will make is that we've seen this with Gutenberg data, we've seen this with Web of Science data. This can also be used for patent data. Since the meaning of the content fields can vary depending on source and patent authority, it is best to be cautious and clear about your research goals. We at Search are happy to assist all VantagePoint users with applications involving patent data.